Picture walking into a cluttered storage room, where items are scattered everywhere. How do you make sense of this chaos? You'd organize similar items together, right? This is exactly what we do with raw data through frequency distribution. A frequency distribution is a comprehensive method used to classify and organize raw data in a systematic manner. When we collect data, it often appears jumbled and difficult to understand. A frequency distribution helps us arrange this raw data by showing how different values of a variable are distributed across various classes, along with their corresponding frequencies. Think of frequency distribution as sorting examination scores of 100 students. Instead of looking at all 100 individual scores, we can group them into classes like 0 to 10, 10 to 20, 20 to 30, and so on. Each class shows how many students scored within that range, transforming confusing raw data into a clear, organized table. Relative frequency expresses how often a class appears relative to total observations. Relative frequency is equal to class frequency divided by total frequency multiplied by 100. If 10 out of 100 students scored between 40 to 50, the relative frequency is 10%. Here are the mathematics marks of 100 students. Calculate the frequency distribution table along with the relative frequency for each class starting with 0 to 10, 10 to 20 and so on. We start by identifying the frequencies for each class interval, which are 1, 8, 6, 7, 21, 23 and so on. To verify this is correct, we use the formula where relative frequency equals frequency divided by total frequency multiplied by 100. So for our first class interval of 0 to 10, we get 1 divided by 100 multiplied by 100, which equals 1%. For the second class of 10 to 20, we get 8% and so on. As a final check, when we add all the relative frequencies together, they sum to exactly 100%, which confirms our calculations are correct. There is another type of frequency distribution which involves two variables simultaneously. It is called bivariate frequency distribution. Here, instead of studying one variable, this kind of distribution summarizes data by showing frequencies of various combinations of values from two different variables. While frequency distributions make data easier to understand, they come with an important limitation: loss of information. When we group individual observations into classes, the specific details of each observation lose their significance. Consider a class 40 to 50 containing these many values. Once the raw data is sorted and grouped into classes, we only know there are 21 observations in this class, but we can no longer identify the exact values. Let's recap.